this is the second part of the FP1 past paper. This is from the qualification MEI OCR. So if you're not doing this particular paper, then please turn away or I will waste your time. So yes, let us continue on the FP1 paper, section B. Now question 7, the sketch below show part of graph y equals that. One section has been omitted, which is the section between these two asymptotes rather. First, find the coordinate of the point where it crosses the axis. So essentially it wants you to find y equals 0 and x equals 0. Let us have a look. Trouble is, I need to copy this equation. Let me write that down on a piece of paper and I can copy that into the computer for future applications. Okay, here we are. So the top, let's say we want to find y-intercept, so x is equal to 0. So the first part will be -1 because it's 0 minus 1, 0 minus 2 times 0 plus 3 times 0 plus 3. That's convenient. So y will be equal to negative cancels 1 over negative 2 times 3, which is 9 times 2, which is 18. So y will cross, the line will cross y at 1 over 18. This is one of the place that it crosses. Now let us find the other one when y is equal to 0. So when y is 0, you have x minus 1, and the bottom part really doesn't matter because when you multiply both sides by the bottom, the denominator will cancel because it's 0. So essentially you only look at the top part of the fraction, and x in this case is 1. So that is relatively simple for the first question. And note, find the coordinates, so you need to find the y, both x and y values, so better put them into brackets to state their coordinates. 1 over 18, this is 0.1, 0.2 is 1, 0. Okay, so there are 2 points and that's it for this question. Now on to part 2, write down the equation of 3 vertical asymptote and 1 horizontal asymptote. Alright, let's cancel that out. So first thing first, let us find all the vertical asymptotes. To find vertical asymptotes, you just make it so that the x value will cause the fraction to become something over 0. So if I have x is 2, then the first bracket will become 0, which is an asymptote. Second, x is equal to -3, it will become 0 and it will become an asymptote as well. And the last one, which is a bit more tricky because it's 2x equals -3, so it's -3 divided by 2, which is -1/2, 1.5. So that is 3 vertical asymptotes. Now on to the horizontal asymptote, which is a bit more tricky to find because you want to find that when x is near infinity, which is a huge number, what would y tend to go? So if we expand the bracket, we know that the top is a linear, the bottom is a cubic. So essentially you can cancel down the things to this, because the significant part when x is 10 to 0, 10 to infinity, is that top will be 10 to x, because the negative 1 will be insignificant. On the bottom, all the x terms, x squared, x, and the constant term will be insignificant because the x cubed is so big. So now you can cancel out this x and turn this x cubed into x squared instead. And in this case, you have something called 1 over x squared, which when x is infinitely big, it tends to 0, because anything divided by something incredibly massive goes to 0. So yes, that gives us the y asymptote is 0. So now we've got these 3 plus 1 asymptotes. That explains one question, which is worth 4 marks. Incredible. Copy the sketch and draw in the missing section, and that part, I believe, in the question paper, the answer booklet will give you a graph, but I do not have one on the computer, so I will have to plot this thing myself. What a joy. Okay, so we've got the asymptotes. If I can draw straight lines, which I cannot today. Incredible. Yes, excuse me a minute for drawing silly lines on the computer. Right, so horizontal asymptote is y equals 0, which you don't need to worry about. Label that x is equal to, this is 2, this is negative a half, this is negative 3. Okay, so in the graph it's given that there is a thing right here. There's 2 pretty simple lines on these 2 faces, and now I need to find this big thing, which is a bit tricky. So what you would do in the exam is to proxy answer by typing values. So you want to do type the answer, type the equation into the calculator, which I will take a minute to do. That's a good way to put x as answer, and you can call up the previous calculations, and you can essentially change answer each time you proxy it. Okay, so now I've got the equation in, and I will type that 1.9 is equal to x, because 1.9 goes right here, and I can see if it is a large positive number or a large negative number. And in this case, it turns out that it is a large negative number. So let's try out something on this edge. Negative 1.5, I will do negative 1.4. And that yield me a positive number, which means it goes from here. And now let us consider our options, because we know the y and x intercept where x is 1, 0, so we know this is 1, 0, and we know the y-intercept right here is 1 over 18. Oh, this is fancy mouse work. And so we can link these 2 points together carefully and join these lines. And so we've got a beautiful curve which explains the equation of whatever that is. So now I think that's it for we need to solve the inequality of that is larger than 0, larger or equal to 0 in fact. So in this case there are 3 sections that are larger than or equal to 0. There's this part, and there's the part within these 2 points. So the inequality that is bigger than 0 is that x must be smaller than the asymptote -3, or x must be larger than the asymptote x equals 2. And the final one, the one in between these 2 points, is that when x is 1, when x is 1 or smaller, so is this symbol. I need to add another line later on, but right now I don't. And the other point would be the asymptote, which is -1.5. Right, okay. So remember to put this an equal sign because it will be detrimental if you forgot about it. Yeah, so this is the answer to part 4 of this question, and now we can move on to question 8 and get rid of this pretty embarrassing graph that I've drawn. 8.1, on a single argand diagram, sketch the locus of the point of that and that. Okay, that sounds fun. Right. More graphs. That's why you have graph papers. And remember to use ruler and compass for this one because we're sketching a locus. So now, you know this is I-axis, this is real axis. I'm not gonna label them because I can't be bothered. Part A, the mod of z minus 3j is 2. Z minus 3j gives us the center, and it's z minus the center, which is 3j. So on this point right here, I can write 3, and this is j-axis, and the locus of mod 2 means the length around this line is 2. So you draw a circle, which this is definitely not a circle. This is of radius 2, so this is 1. Label r equals 2, just for the reason of I'm just sketching. You need to plot it on a graph paper, which will make a lot more sense. Now argument of z plus 1 equals 1/4 pi. So now we have the argument of this, so first find the center of the argument, which is z minus a number, so that number must be -1. So the -1 is right here, so -1, this is the center of the arc, and 1/4 of pi. Well, this whole circle is 2 pi, half circle is pi, this is half pi, and therefore 45 degree is 1/4 pi. Oh, surprisingly straight. Okay, now I've got that argument done. Now part 2, indicate on the argand diagram the set that is smaller than or equal to 2 radius from this or and the argument that is smaller than that argument. So essentially it wants something in between the x-axis and this line, and yet within the circle, which means the only place is this entire strip are filled with the requirements. So we have to indicate the set of points which you shaded in with pencil. Remember, drawing graph, always use pencil because that is a lot better than using pen. But especially when you make mistakes, you can change what a pen does. Okay, part 3A. Drawing an appropriate line through the origin indicate the point that this an argument z has its minimum possible value. Okay, so this means that the line through the origin must touch the circle by saying this, because it must be on the circle. This is a circle equation that it's given, and it's equal, so it can be whatever outside or something like that, and the argument z has its minimum value. So essentially you want to put a ruler horizontally and rotate from the origin anti-clockwise until it touches roughly the circle. So what I'll do is a ruler like this, latch on until it touches this circle as a tangent, and you draw a line through it. And so here we have the third answer, which is this line. Yeah, that's a simple 2-mark question. Okay, calculate the value of argument z at this point. Okay then. This is more complicated than I thought. So now you need to use the graph to actually find the point of which it touches, and I do not have that, so I'll pause the video, look up or actually plot the graph myself and have a look. So I'll be right back. Right, done. It turns out that if you look horizontally, you get 8, and if you look vertically you get 9, and it lines up as a right angle triangle, and you can use tangent in radian form. So it is arc 10 9 over 8, which will give you a value of 9.844, and 3 significant figures always will always work, so leave it as 0.844, I guess. So now we're done with this question. Question 9, A transformation. Is it A trans? No, it's A transformation T. The capitals are trolling me. A transformation T acts on all points on the plane. The image of a general point P is denoted by P dash, and P dash always lies on the line y equals x and has the same x coordinate as P. Now write down the image of the point -3, 7 under transformation T. In this case, we can see this is a many-to-one transformation, so essentially the matrix won't actually work reversed. So it told you in the question same x coordinate always, so it keeps the x coordinate and the y coordinate changed to the equation y equals x. And so in this case, we've got a -3, 7, and if we keep x and make y equals x, it's -3, -3. So this is part 1 mark. I think it's fair. Write down the image point xy under transformation t, and xy will become xx because y changes into x, which is quite trivial. Find the 2x2 matrix. Now this one requires a bit of a step. And once again, this is a transformation A, B, C, D. And we're mapping x, y onto x, x. I wonder, how would we do this? First of all, give it a bracket. There we go. And now we do our algebra. Ax plus by plus by is equal to x, and cx plus dy is equal to x. And in this case, we can show that a is equal to 1, b is equal to 0, c is equal to 1, and d equals 0. So the matrix of the answer will be 1, 0, 1, 0. And that is, I think, 2 marks? 3 marks. Okay, now describe the transformation M represented by 0, -1, 1, 0. If you are a diligent person, you would have remembered this thing, but I am a lazy one, so I will derive it myself right here. 0, -1, 1, 0. -1, 1, 0. Okay, how do we derive a particular matrix? Well, first of all, you need to give it some points to translate. So say unit square, we've got 1, 0, we've got 0, 1, and we've got 1, 1. Let us look what does it transform to. And we can do a matrix like this and still multiply because the horizontal is the same as the vertical, which I've explained in my Further Math GCSE matrix video if you haven't watched. 0, -1 marked to 1, 0 goes to 0 because it's 0, 0. Then 1, 0 marked to 1, 0 is 1, 0. 1 plus 0, so that's that. Second part, second one is -1 times 1 plus 0. Then this one will be 0. And up here we have a 1, 1, so this will be -1, and this will have to be 1. Okay, so now we have 3 different points marked from this, and we can do a small sketch to get the feel. If I can draw a vertical line without... Oh, this is actually very, very straight. Okay, so 1, 0, which is right here, has became 0, 1. So it went here. 0, 1, which is this point, became -1, 0. And 1, 1, which is this point, became -1, 1, which is this point. So instead of this unit square, we got this unit square. This is a new one. And so we can see that this is actually a rotation anti-clockwise by origin. So anti-clockwise rotation at origin by 90 degrees. There we go. So this is it for this particular part. Now find the matrix represent composite T followed by M. So you multiply M by T to get MT. And M is 0, -1, 1, 0. T, on the other hand, is 1, 0, 1, 0. And I see that this will be a detrimental problem. If someone can't do question part 3, then you lose basically the rest of the marks, which is a bit bad, but well, exam boards, I can't explain a lot about them. 0 times 1, -1 times 1, which is -1. Then you get always 0 on the right. Then the next one is 1 and then 0. So if you can follow that, because this is matrices and it's not particularly easy to follow. Now find the image of the point xy under the composite transformation and state the equation of the line which these things lie. Okay, so now we have one equation and we can put xy under it and do the same thing we did not long ago. Instead, we are finding the next value instead of reverse engineering the matrix. Or there's another way of doing it, is that you play smart and say that because I am currently marking everything onto y equals x, I will mark after 90-degree turn a y equals -x line, and that works. But let's do it the matrix way. So this is a -x because then this is an x. So now looking at this, x is equal to -x and y is equal to x. And so because of this, you know that we're using x as fundamental, and if you substitute this into this equation, you get y equals -x, and that is the answer for this final part. So that's it for this past paper, and it's a relatively simple past paper, I would say, for an FP1. It is quite basic, and there are a lot of good questions. And so yeah, if you do enjoy this video, or if you do learn something about this, feel free to drop a comment in the comment section below, and I will see you on the next past paper.